So the next thing that we'll do is we'll look at how we can perform regression using a basic kind of a spreadsheet. Here I'm using Google Sheets. This is very similar to what would happen if you were using Excel or anything like that, numbers. And we have some data about advertising. So the data here is each of these rows is a market. And actually, this is where the data ends. The sales, the newspaper, radio, and TV. And these are different media types that we invest in for advertising. And we get out of that market this much in sales. That's the idea. So we want to see if we can explore the relationship between some of these features. And in this case, we'll just look at the relationship between television and sales. So to start, let's draw a scatter plot of these two series. So I can just select it by clicking on the top, hold down Command. You can select multiple things, and I'll just insert a chart. And all right, there's my scatter plot. And again, I'm saying that my investment in TV will output some amount of sales here. And to develop a line of best fit, we're going to rely on those equations that we just derived. Okay, this is just alpha and beta written a little differently. This is more conventional notation and a lot of text. They'll refer to alpha as or A as beta 0. That's the intercept, and beta 1 is B. That's our slope. And remember, we just have pieces that are relationships between the data and summary statistics of the data, the mean is in particular. So those are fairly straightforward to calculate, and that's what I have in each of these columns is, for example, in this XDiff, I'm just taking the difference between the values in television and the value of the average from that column. All right, and that'll get me this term. And then I can look at YDiff, same thing. That's just every Y value minus the average of Y, which our Ys here are sales. And then we need this, that difference squared. So that's what this x squared column is. It just takes that difference and squares it. And finally, we need the product of those differences of x and y's. So I just have a product of those two. And then these expressions just rely, this beta 1 relies on summing that column of the product and dividing it by the sum of the difference squared. So just a sum of this product column divided by a sum of those x squareds. And what we get is our value for beta 1, or the slope of our line of best fit. And then we can just use we put those together, the average of y, the average of x, and what we just found for beta 1. And that is our intercept term, right? Average from E, which was the y values. Beta 1 is what we just figured out. X bar is the value, the average from TV. All right, and then we get back 7.03. So what that means is our equation is 0.047536640 so on times the amount that we've spent in television plus 7.03. So that means that if we assume there's an intercept term here, we're saying if we don't spend any money on television advertising, then we'll still have sales. So maybe that is or is not a good assumption. But again, that's something that we'll need to decide. And we could also, this is actually built into Google Sheets and most of these spreadsheet programs. If I go to edit this chart, I can look at the series, add a trend line. I could also add error bars and things. And then I can view the equation if I change that label. And sure enough, the equation that Google Sheets came up with, 0.0475 times x plus 7.03, is identical to what we determined using the formula that we derived.